Alrighty, you ready to have your minds blown? No? How about have a few neurons toasted? I think I'm gonna take a couple of shots before we get going because I haven't done a video in a minute and I'm quite rusty, so let's get through this as quickly as possible. Really quickly before we get to the graphic presentation, this is about two possible interpretations of zero, and it has actually unraveled into something far more profound. If you're interested or if you have not heard of this, you can Google it online or, wherever else you Google things other than online. Anyway, that's why I need this. But, so yeah, you are sure to find some kind of rogue mathematicians blogs out there. It's not a really hotly debated topic. Some mathematicians believe that the possibility of these two different types of zero could turn out to have some profound impact on mathematics, which kind of is what this is about. So, without further ado, is there anything else I want to say really quickly? Nope. Let's get to it. Okay, back in 2010, 10-ish, I think, I saw a documentary called The Boy with the Incredible Brain. I'm going to give you some backstory really quick and how I got to this conclusion, because I think context it's important when you're talking about something as complicated or something that can be as complicated as mathematics. So this documentary was about this young man named Daniel Tammet, a British kid. And he's a savant with synesthesia. So, okay. The fascinating thing about this, I highly recommend watching this documentary, by the way. It's really, really interesting. But when I saw it, I was just totally drawn into the entire everything about this kid. He describes his process of, okay, back up. This kid can perform insane calculations in his mind. And the odd thing is that he doesn't even know how he does it. He describes the process as seeing, first of all, if you know what synesthesia is, there's, you hear colors, see sounds, feel tastes, that kind of a thing. Your senses are crossed. Sensory input from one sense will cross over and create like the quality associated with another sense in sometimes extremely dramatic ways. But so with this kid specifically, he describes, each number as having a very specific shape, color, feel, essence to it. I can't remember everything, but like the wetness of water, but dark and cloudy with some specific shape and like some overtone, and it's sparkling kind of a thing. Like just a lot of really bizarre, I guess quality is the best term to describe these, separate things, but all come together to create one specific number. And the way he describes the process is that in his mind he'll see, some number representing like 5,204, and it would be shaped like this. And there would be another number, 1,001, and it would have some, shape like this. And the way it's described in the documentary is that in his mind, as he brings these two shapes together to perform some calculation, they will, some third shape will emerge in the middle of the two, and something like that. And this is instantly, he just knows right off the top of his head that this is instantly the answer to the question. And because that shape that they created, he already knows as that particular number. Really interesting documentary. But this is what kind of kicked me down and started me down this road of playing around with this concept. So I thought, wouldn't it be interesting to see if I could come up with a system like that anybody could do in their head, but that had a little bit more order to it, not so much random craziness. So I set myself two constraints to follow in engineering a mathematical model that somebody could do in their head. Somebody could perform this in their head. This all will come back to zeros. Trust me, I'm just kind of explaining the background here. So the first constraint I gave myself was that it had to be totally natural and wholly intuitive, meaning that you could go out and grab a life form from Alpha Centauri, an intelligence, say, and you brought them back to Earth, and you could set them down and project a simulation of this system in front of them, and you could project this in front of them, and after a couple of moments, it would be, the basic rules would be so simple and so just obvious that this alien from another world would be able to pick up on the basic rules like that. So that's the level of just this natural intuition that I want to be able to, I want this system to be able to just encompass. The second constraint that I set out for myself in designing the system is that it needs to be easy for anybody to perform extremely complex calculations in their mind alone, without the aid of pencil, paper, calculator, anything else, fingers, nothing. That they'd be able to just close their eyes for a second and perform some insanely mind-blowing calculation. Tall order, I'm aware, but I've made quite a bit of headway, and I'm going to explain some of it to you because this is what sort of opened my eyes to what is happening in mathematics. Okay, so the system I came up with, or where I'm at right now, these are the, I guess, kind of basic properties that it has at this point. It's still progressing. I only work on this in my spare time, so it's not something that I have been hammering away at, but I've been putting a fair amount of time into it, at least for the last year, 8 months-ish, something like that. So the first property is that it has a triaxially rotating base 8 rational system. And yes, rational meaning having to do with fractions. And this I totally stole from Star Trek, but it actually fits really, really well with what is happening here. So the triaxial rotation, right? You've got 3 axes, correct? So let's I forget what the proper right hand. See, this is X, that's the Z. So Z, X, Y, is that right? So this would be Y, X, zeta. Okay. Actually, before I explain that, let's explain this, because it kind of has a lot to do with why it's like this. So the second aspect to this is the subject, or the geometric shape that you're dealing with. Its orientation, which is a base 64 system. Let's say this is the cube. Okay. So this cube, each face has a unique property, and it's not always a cube. In fact, it's almost never a cube. It has to be something that you are extremely familiar with in the 3D world, that can represent that system. So, for instance, a human head. Okay, a human head. It's very distinct. No matter what angle you're looking at a human head, you know it's a human head. Usually. So, however, man, I don't even know how to explain this. In fact, it's not even really that important. Let's just say, as you rotate the human head around, right? You have one rotation from all the way around, like this, on this sort of plane. And then you would have a rotation all the way around, 45 degrees down, like that, all the way around. On that plane, then you would have straight up and down, where the nose is pointing down, and they would rotate around 45 degrees up, all the way around, and then pointing straight up all the way around. At each step, 45 degrees. 45 degrees separates all of them, because I don't think we're capable of really deciphering more distinct iterations through rotation without losing some people or coming up with problems or issues. I think a 45 degree angle, 90, 180, or whatever, 115, I can't remember. Okay. So, but not only can you do this sort of rotation all the way up, but you can also do rotation around each axis. However, there are some circumstances where some axial rotations will cause a duplicate perception, where you're going to have a collision with an already previously defined value. So this is why we are doing this triaxially rotating base 8 system, which helps avoid those collisions completely. You just avoid those collisions up 100%. So these two systems together, this and this, give you so these first two systems together give you the means to operate on your set of 3D objects effectively, efficiently, easily. Will not operate on them, to orient them and create values from their orientation. Okay, this third system as a base 64 proprioception integration, which brings the user, or the person performing the operation, into the calculation itself. Proprioception is your ability to sense your position and orientation in the space around you. So using proprioception, or a kind of a pseudo proprioception and infringed proprioception, you are inserting yourself into this operation space, which allows for much more than just the base 64 values and operations that it's listed as, but that's aside from the point. And the fourth one is the frame of reference space shape, like the interaction space. So you've got your user, you've got your objects, and you've got your operation space, which is how you orient things and connect them to perform different operations. This is a sparse distribution system, meaning you don't want every corner of your operation space filled with some object in some orientation. That's specifically not what you want to do, because you are going to totally forget what you're doing, and it's not going to be worth what it is. So that's a really brief overview of where the system is right now. So that's a really brief overview of the system. For now, I'm not planning on going into any more depth in this video, don't worry. But one of the main components to deciding how this operates and how the system works turned out to be, obviously, or once I tell you, you'll be like, oh yeah, that sounds about right, is the symmetry of the system. Before we move on, this is something that might be interesting to you. As of yet, this frame of reference space, its base is undecided, and I don't even know if it could be technically called a base. However, as the system stands right now, the total base capacity, I guess, of the system at this time is 194,000 and 104. I think it's 304. So yeah, this system is base 4 million. It's pretty incredible to consider that there is a system that you can construct and utilize in your mind that is base 4 million, that you can actually understand what's happening. Like, as this gets developed, I'm sure I'll make more videos and do more things with it and show people more and more how to use it. But let me just say this: you're not going to get confused with what is what. As soon as you understand the system and how it works, there is no confusion. Even though this sounds like a completely ridiculous concept, to be able to have a base 4 million numeric system locked up in your mind, you don't need to memorize each individual orientation and interaction. The way it's designed, you already know. Like, it's just like I don't know how to describe it without going into like extreme detail with how it works, but I don't know. Moving on. Okay, so as we all know, symmetry is an extremely important part to mathematics. You could almost even say that symmetry is well, I don't know, the foundation upon which mathematics is built, or you could also say that 0 is kind of the apex of symmetry, of mathematical symmetry. It's the center point, you know. I wouldn't call it an equalizer, but it's kind of the focal point, or the fulcrum that the number system balances on. In developing this system, I came across some really frustrating problems that after some good amount of like reflection and trying to figure out what exactly is happening, I realized that the problems, plural, that I was having were because the fundamental symmetries of mathematics were being broken. That there was something that was causing the symmetry to break in my system that wasn't allowing the proper flow of the equations and the calculations to come out correctly. And so as I was realizing that there's this actual problem with symmetry here, there's some sort of fundamental symmetry that I was breaking, that something in my system was just, I don't know, it just wasn't allowing the system to work as mathematics should. So as I began to investigate exactly what was happening here, the only way I could really truly figure this out was to isolate the problem and create a new system that I could, a new sort of targeted system that I could use to really try to find where these fractures were, what they were, why they're doing what they were doing, and eventually solve and fix these problems. Now, what I came to realize was that, man, and I hate to kind of point to the idea that there is some sort of Platonic system of mathematics that just kind of has previously existed. It appears that there is. And now I wouldn't say it's, as Plato believed, like some other sort of kind of shape spirit realm that kind of embodied all of the basic ideas of what everything was. But there is something that will throw you off. And I'm still kind of baffled by this, but there is something in the way that the numbers work and interact with each other or how they should. And when you're working on any one problem, no matter whether it's selling onions or weighing, apples, or taking body measurements as you're, working out and trying to lose weight. There's something fundamental about how numbers work that if you construct your system of mathematics incorrectly, not only will it, this is so crazy. It appears that I don't want to personify math, okay? But it's almost as if, and this may be something, well, I'm almost certain that this is something to do with how our psyches operate, but it's almost as if mathematics has a will to survive and to self-repair. And one of the examples I have run into so far is complex numbers. Okay, let's move on. So, what I have come to determine here is that mathematics, that we have two different kinds of zeros. Like I said previously, if you search us, with Google or Bing, if you choose to go down that route, you will find that there are some, it's like I said previously, it's not a hot topic. It's not something people discuss with passion, but you will discover that some people believe that the difference between these two types of zeros could, or they have this intuition that it could cause differences in how calculations are performed. So let's dissect that. I have chosen to use the elongated zero with a slash through it as the null zero, and the circular zero with a slash through it as the not. Even though mathematically, if you look in, if you look up the mathematical null, right, they will use the circle with a line through it for null. But I've found that this is more reminiscent of something not being there. Right? That there is no smoking, Ghostbusters, whatever. And the null, this elongated zero, I just kind of think it, I just like it a little bit more. Okay, so what is the difference between null and not? The not zero and the null zero. The fundamental difference, the only difference, the thing that is making this, that has turned this into a whole thing for me, is that the not zero represents the utter absence of something, the absolute non-existence of any one thing. For instance, I have $0 in my pocket right now. There's nothing you can say about that. I simply have no money in my pocket right now. That, in contrast to null, what null means is, well, let's shoot through some examples, because this is fundamental. Understanding this not null difference, and these are terms I have come up with. Okay, if you go looking these up, you're either going to find something conflicting or something just not in line with what I'm saying. These are the symbols that I have chosen. Okay, I've decided null for the cancellation of forces, and I have decided not for the simple non-existence of something. Okay, let's move over here. Okay, so for not, like I said before, the not zero simply refers to something just simply not existing. This would be used in calculations of debt, calculations of produce or money lacking, of things, calculations where your representation of something is a representation of that thing not existing. So, like this, okay? I previously had 3 apples. Now I have 0 apples. This is a not zero. And in fact, this has actually got me wondering if we have 2 different types of zeros, if there aren't 2 different types of negative numbers. And this is what we're going to get into in a minute here, because this has a huge impact on this whole everything. Okay, this is an example of null. Let's say we've got a sound wave, some music going in the room or whatever, what have you. A wave in the pond, doesn't even matter. Waves are composed of, not composed of anything. It's just difference in energy. There's longitudinal waves, there's seismic waves, there's all sort of different waves. Are waves seismic waves longitudinal? No, they're not. I can't remember. Okay, doesn't matter. All right, every wave's got a crest. Well, not every wave. Compression waves. Trough. Okay. Now, in order to cancel out a wave, if you introduced a secondary wave that was exactly the opposite, where this, the crest of the blue wave is 10 units, then the trough of the red wave would be negative 10 units. And it's, what was it called right here? I can't remember. But where they were synced up such that that the trough of one wave would cancel out the crest of the other wave. Okay, so the result of this system, if you've taken physics classes and you totally know, would be something like this. You literally would end up with nothing. Now, what's the difference? Okay, what's the difference between this kind of nothing, all right, this zero, and this zero? What exactly is the difference here? And the difference I have discovered actually has to do with the fact that this isn't nothing. This one right here, this is not nothing. This is the resulting value of 2 opposing forces interacting. All right, so a good example of this would be tug of war. Okay, you've got one guy, all right, he's heaving and pulling at this rope. Well, you got this other fellow right here, right? He's doing the same thing. And he's tugging at this rope. And let's say Joe and Ken, why not? Joe's pulling at 10 units force, and Ken is pulling at 10 units force. The difference between this is that they're both pulling at, even though it's the same force, it's the same type of force, it's the same units of force, they're applying these in two directly opposite directions. So Joe's pulling this way, Ken's pulling that way. Well, because they're both exactly, I don't know, supernaturally both pulling at exactly 10 units of force each, you will end up with absolutely no movement at all whatsoever, and your net force is going to be 0, or as let's use the correct 0, the elongated 0, like this. Okay, you're going to come up with an absolute net force of 0. But, well, what's the problem here? The problem is that it's not 0. The problem is that Joe is actually exerting 10 units of force, and Ken is actually exerting 10 units of force. You don't have a true 0 here. You have a nullification. It's the canceling out of two opposing forces. Hopefully you can see why these two different types of zeros kind of have been in the back of some mathematicians' minds for a while now, that they seem fundamentally different. They seem like there is something that should cause them to, force some calculation somewhere to come out differently. And the fact of the matter is that there is. You just have to do it right, or kind of right, or approaching what is right. Here's another thought I've often wondered. This really doesn't have anything to do with this specifically, but I'm just going to throw it in there just in case anybody cares. I've also wondered about even using 0. I think because of what 0 represents, there are very few cases where you would want to actually, convey that there is an absolute nothingness, that there's not something there at all. And I think it might, I don't know, I'm going to have to put some more thought into this, but one of my thoughts is, what if instead of using 0, we use like a limit, right? Where we use a 0 that isn't really 0, that basically represents a limit approaching 0 from either the positive or the negative side. Wow, I just stuck my foot in my mouth. You'll see in a second here. This positive negative thing, we're going to have a little chat about that. Okay. So let's get to the kind of the meat of this whole thing. All right, so we've got your null 0 and your not 0. And so the question is, well, is a null-based system different from a not-based system? Are there null negatives? And what about not-based negatives? Well, it turns out that the not-based system is pretty easy to dig up here, simply because the not-based system is, in fact, the traditional mathematical skeletal structure. So let's just whip on over here really quickly and take a look at this. So your not-based system, right, is is your traditional system. And when I talk about the symmetry of a mathematical system, I'm not necessarily talking about its, the number of lines geometric properties, though it is interpretable like that. You can interpret that. You can interpret it in a geometric fashion simply because that's the easiest way to interpret it with. But so with a not-based system, your number line, the entire number line, going from negative infinity to positive infinity, is a single unit number line. You're talking about the same unit all the way, both ways. So that's its base symmetry. It's a sort of a one vector kind of symmetry. Okay, and that is why the Cartesian coordinate. I know this isn't totally even, but you get the point. The Cartesian coordinate system is the way it is. Okay, so in the traditional number-based system, you can do something like, say, 3 minus negative 5, and that is actually the same as saying 3 plus 5, correct? Okay, but because of the symmetry of the system, doing something like 3 plus positive 5 is still the same as saying 3 plus 5. Even though you are dipping into, I guess, the sign's representation of the negative side of the number line, a positive and a positive still equals a positive, but a negative plus a negative, or a negative, subtracting a negative equals a positive. And that is inherent in the symmetry of the system. Okay. So now we're going to get a little crazy, and we're going to move over to the other side. And let's take a look at this for a second. Okay, a null-based system. Now with a null-based system, you can't have your traditional addition and subtraction. You have it in a manner of speaking, but it works differently. And let me explain why, and I'll show you why. All right, this guy up here. Whoops. We're gonna. You see the 0, our null 0 right down here. Okay, this is the center of a number line. Not this number line. Okay, this number line center is right here. We're gonna hit that in a minute, or right here somewhere. But let's just say this is a center of a number line. All right. Now, because we're dealing with two separate values, we're dealing with opposing forces, and because of that, for instance, let's say, in fact, let's kind of blow this up a little bit. When we meet in the middle, when it zeroes out, when the forces cancel each other out, we would have something like 10 units, and let's call it the right side. So 10 units right. And over here, we've got 10 units left. Okay. The same amount of force. They are just moving in opposite directions. They're wholly opposing each other. And hence why they are perfectly canceling each other out at 0. If we were to have a situation like the second one here, there are two ways to come about this situation. One would be to have the UL, okay, the UL lose a unit. So it would be 9 UL against, I know that's not, let's just use that, against 10 UL, or 10 UR, okay? So that's where we're getting offset and we're moving into the 1 UL range. Now, the second way this could happen is if the UL stays 10 and our UR bumps it up to 11. Okay. Same thing with this down here. If you want to, you know, the two situations that could cause it to shift over like that is this side becomes 11, and whereas this side stays at 10, or this stays at 10 and the other side drops down to 9. So you can see that there's more than just one thing at play here, and on top of that you have two separate unit amounts, two separate systems, okay, two separate systems that should maintain their value even if they're canceling each other out. The value should be maintained and should be tracked. And I'll show you why in just a moment here. So the operations that I came up with, they're fundamentally addition and subtraction, but in a way that gives this whole dynamic, this dualistic sort of nature of this method utility, more freedom. It gives it more whatever, you know what I'm saying. It makes it utilitarian. It makes it a tool. It makes it usable. Okay. So the four operations are these top two right here are increase and decrease. Now these should be used for your upright numbers in the number line. And I know you know that you don't know what that means, so let me explain that to you really quickly. Let's just mark this out really fast. So that is not the middle at all. So we're going to pop the middle down right here. Okay, this is 0. This is null 0. All right. And I guess that kind of did the job for me. So let's call this 1. 1. Yes. And we've got 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, remember I was talking about the symmetry of the system. I was trying to convey the symmetry, the weirdness of the symmetries, and come up with a solution. So what I came up with is to just mirror and flip the numbers. That way you know which is which. And it turned out to be fairly easy to adapt to. So we've got 1 down here. We've got 2 there, 3 here, 4 here. That is totally in the way. So we'll do 5 there, 6 there, 7 there, 8 there, 9 there, and 10 there. Okay, the reason I did this is, 1, to get rid of the negative sign, because having anything other than some sort of mirror version of the numbers to represent the left side of or the left what's the word I just used earlier? The left system would indicate that it would just put out the wrong connotation. It would be too similar to the traditional number line, and we want to avoid that at all costs, because it carries so much baggage with it. There's too much, just mentally falling into that groove of, just negative and positive. That's not what's happening here at all. That's just completely not at all what's happening. So the way we can scratch out these operations, okay, if I had, let's take a right system 4, and I increase it by right system 1, that's going to give me 5, right? Obviously. If I take a right system 5 and I decrease it by 2, that's going to give me 3, right? Now, it gets tricky when you start mixing things, because you need to make sure that you are maintaining the value of that system. If it's the left system or the right system, you need to ensure that whatever you're looking for, whatever the number is you're looking for, you need to maintain those variables, or whatever that amount is, to make sure you get the right value. Because if you don't, you're gonna screw it up, and you're going to remove value where you shouldn't have, and vice versa, or add value where it shouldn't be there, and you can quite quickly screw up your calculations. But to continue, our next set of operations is submit and impede. Now, this is in the case that the two systems are interacting. For instance, let's say, okay, like right here, right? This guy right here. And let's look at this one, where your left system loses a unit of force. Well, from the right system's perspective, it would appear as though it has submitted. It's given up a unit of force, and that empowers you to move things over. I'm personifying a little bit, but don't worry about it. It's getting the idea across, right? So, likewise, impedance is just the opposite action. It would be something akin to this, where the left side gains a unit, 11 to 10, and so its impedance heightens. Its impedance goes up. Well, this gets interesting when you start doing things that would be similar to, right, and like on the other side, where you have something like 3 minus negative 5. Well, how would you even translate that into a null-based system? 3 minus negative 5. Okay, so that's your traditional layout. So let's take the same value. Let's go 3. Okay, And here, look, the question is here. Okay. Minus, that's fine. We know what minus is. Okay, that's decrementing, that's decreasing. So we'll plop that down there. But -5, what exactly are we talking about here? What is -5? How are we going to interpret this? There's two ways to interpret this. One would be to, again, decrement +5 like this. Okay. Another way would be to say let's see. So 3 decrementing the 5. The left system 5. Okay. These two are the differences between these two types of interactions, and the outcome, depending on you know what sort of operation you're trying to conduct here, is going to be radically different. So if we are doing 3, we're decreasing -5. Okay. Now -5, just like the other time, the other one is a subtraction of 5, right? So 3 subtract 5. No, I'm sorry. 3 subtracting -5 would end up being similar to what happened in the other on the not-based system. So it would actually come out to be something close to, it would actually come out to be an increment, so, and 5, which would in fact equal 8. But if we're dealing with an impedance or a submission, okay, so we're 3 decreased by. Okay, so we instantly know we are going to start decreasing. Whatever is after this, we know that the operation is going to be a decrease in something. Okay, but now the 5 here, well, it's an upside down 5, so we instantly know that it is a left system value. Well, how do you decrease a left system value from a right system? The only sensible mean or sensible way is when you're doing something like this. Okay, it's when you are, or when the other side is submitting or relieving 5 of its units, right? So it's submitting. It's not impeding. It's submitting, because the 3 is nope, I got that backwards. Okay, no, that's incorrect. The 3 is decreasing. Okay, and so the 5 is from the other system, and because the 3 is decreasing, then we are getting an impedance. All right, so it's an impedance that's happening. The 5 is impeding the 3 because that is causing the 3 to lose, or causing the right system to lose the battle. Okay, so this could also be written as and the answer to this, man, this gets complicated sometimes. You start staring at these upside down numbers and trying to deal with all these new operations, and it gets confusing. I'm sure I'll get used to it sooner or later. But, okay, 3 right system is being impeded by the left system, an additional 5 in the left system. So, yes, he says, okay, so the answer isn't necessarily have anything to do with the value, the right system value, but has to do with where they cancel each other out, where the cancellation is going to happen. So that would be that would be negative, or that would be hold on a second. Now I've got to draw this out. Okay, now I'm getting confused. So this is going to come this way. It's going to be 2. Okay. It's going to be right side up 2. It's going to be right system 2. All right. Sorry. So, are you following? I'm sorry if I'm making this confusing. I'm still getting used to this, and there's still a lot of like crazy shit I'm trying to like figure out in my head, including something fairly unique. And let's bump it up just a second and start talking about multiplication. And I'm not going to make this too abstract. So let's deal with, a single system multiplication. So let's say 3 UR right system units times 3 UR right system units, right? You are going to end up with 9 right system units, correct? Okay. Similarly, if you have 3 UL times 3 UL, you're going to end up with 9 UL. The sign, even though it's not really a sign, the system maintains its coherence. It keeps its units and everything. Whereas in the not-based system, you try to do this. 3 times 3 is 9, but if you did -3 times -3, you would also get 9. So both of these would equal the same 9 of the positive side. Whereas here, that's absolutely not what is going to happen. You end up with 3L times 3UL, you're going to get 9UL for the left system units. Same with right system units. 3 times 3, you're going to get 9 of the right system units. Which brings up a fascinating point with the number 1. You probably already know where I'm going with this, but if you have the square root of 1 UR, what's the square root of 1 UR? It's going to be 1, correct? Okay, so 1 equals the square root of 1 UR. Likewise, 1 equals the square root of 1 UL. Which means for a null-based number system, the complex numbers begin to get a little interesting. and I haven't really. I mean, I've messed around with this a little bit, but I think what may end up happening is I don't think you get imaginary numbers the same way you do with a not-based system. Your imaginary numbers, right, would be something akin to a unit circle, and you have your 1, I, negative 1. But here, you're obviously do not end up with a negative 1 anywhere that can be square rooted or rooted, which means you don't end up with I. So I think there's a tendency to oscillate between the two sides back and forth, but it's not. I'm not sure, but I think it's interesting to note that possibly, as far as I know, almost anything in mathematics that requires imaginary numbers should be using a null-based system. Think about electronics, okay? When you're using when you're using your imaginary numbers to calculate the phases of an AC circuit, and right, you've got two systems, and I wouldn't say that they're the system itself, they're not opposing systems, but they are concurrent systems, and you can end up with phases that will cancel each other out. So this would be a better way to model that system. Maybe I'm not going to throw that out as a fact just yet, but this could be a better way to model that system. But if it is, then it brings up the question of, okay, well, how are we going to use the imaginary numbers? How are we going to use, is there going to be imaginary numbers? Is this enough? Is it enough just to have the square root of 1 UL and the square root of 1 UR? I don't know. This would take a lot of time to dive into this, and like I said, this is the only reason I'm doing this particular model is because it resembles, I wouldn't say they're problems, questions. It resembles questions that I'm trying to answer in my, in the mind-based model that I'm working on, that I'm still having a hard time with. But I guess that's that. I think that we're missing something here in mathematics. I think we need to at least consider thinking about a null-based system and a not-based system, because they end up producing radically different concepts. Oh yeah, and I was going to bring up graphing. So like over here, we've got your traditional, right, Cartesian graph, but over here, the graph, I think the best way to utilize a graph like this with a null-based system is, as it is, you have your opposing forces, but these guys, okay, this line, what would normally traditionally be your y-axis, would no longer, I mean, I suppose you could use it to represent a different measurement that's has some sort of relationship with the measurements across your UL and UR systems. But I think it's interesting to note here that this specifically could be used to as multipliers, and that's another reason I was thinking about the imaginary problem, or the imaginary number complex numbers problem here, is because this could technically be used as a standalone system with just your 2 units and with the extension of unit multipliers. So like, for example, okay, U3 or UL3, 3, right, upside down 3, times itself times 3 would be 9, correct? And if you took the mirror, if you mirrored everything across this axis and brought this down here, you would get the same thing for the other guy. But then you have to ask yourself, well, then what's this space for? If this is the multiplier for UL and this is the multiplier for UR, what are these spaces for, right here and right here? And I think this could be kind of an interesting area, in that this is kind of where the 2 systems would interact, or their units could interact in a unique way. For example, how would you say 3UL times 3UR, and what exactly would that mean? And yeah, I don't know. I'm getting tired now, and I'm just starting to ramble about stuff I still don't even have a clue about, so I'm just going to stop it there. But I think we're doing it wrong. That's all I have to say. I think we're doing it wrong, and I think there's something incredible to be found here. I think we've been missing something. This was way more mind-blowing when I first kind of figured this all out. So I hope it was still interesting and mind-blowing. God damn, this is going to be long. So bless your heart if you fucking watch this. I am sorry. All right, guys. That is that. Bye.